Hi everybody, I want to go over the answers to the first half of worksheet 4 that you guys received before this long break. Number 1 says a race car initially traveling at a constant velocity accelerates at a rate of 12 meters per second squared for 5 seconds. Travels 200 meters during that 5 seconds. What was its velocity before it began accelerating? So I'm going to underline some stuff here. That's our acceleration. That's our time. 200 meters is going to be our displacement, and we're looking for VI. That's a question mark. So A is 12, T is 5, and delta X is 200. Now I'm not worrying about writing out units here because everything is already in meters and seconds, so I don't have to worry about anything being in strange units. The equation that can help me find VI with the information we've got is the first one. So delta X equals VIT plus 1/2 AT squared. I've got 200 equals VI times 5 plus 1/2 times 12 times 5 squared. So 200 equals VI times 5 plus 150. Subtract 150, you get 50 equals VI times 5. Divide by 5, and your initial velocity was 10 meters per second. Now we're also supposed to make a graph. So 10 was our initial velocity. At 5 seconds, we've gone 200 meters. That's going to be the area. We know that our slope is going to be 12. So in 5 seconds, 5 times 12 means we're going to be at a velocity of 60. That's just having a rise over run of 12 for 5 seconds. So there's our graph. The area here, like I said, represents the displacement of 200 meters. Next question. A 747 needs to reach a speed of 80 meters per second. That's VF. On the runway in order to take off, accelerates from rest. That's our initial velocity. What acceleration are we looking for to take off after a time of 40 seconds? So VF is 80, VI 0, A is what we want, T is 40. So looking at the top of the page, the acceleration, or the equation we want is VF equals VI plus A times T. So 80 equals 0 plus A times 40. So divide by 40, you get an acceleration of 2. Again, I didn't worry about units because everything was in meters and seconds. This problem also wants a graph, so our plane starts from rest, so 0 velocity. 40 seconds later, it has a velocity of 80 meters per second. And I know that the scale on this graph that was given to you is not very great. That's okay. That's what our graph would look like. Finally, number 3. A 16-year-old new driver is going 15 meters per second. There's your initial velocity. When he sees a 10 meter per second sign ahead, he slows at a constant rate, and 0.05 minutes later, that's going to be our time, he reaches the sign going 12 meters per second. There's your VF. We want the car's acceleration A. So we don't have displacement. We would use the VF equals VI plus AT equation. So 12 equals 15 plus A times, we need to use a time here, 0.05 minutes. If you divide that, multiply that by 60, because there are 60 seconds in a minute. This is 3 seconds. So we subtract 15, you get negative 3 equals A times 3. Divide, you get negative 1 meter per second squared. Now, does it make sense that we have a negative acceleration? Yes, because our car was going 15 meters per second, and it slows down to 12, so it has a negative acceleration. So on our graph, we start out at 15 meters per second, and 3 seconds later, we're going 12 meters per second. So there's the first part of the graph. Part B then says use your graph to figure out how far after the sign he travels before he's driving the speed limit. So, kind of to make a visual for this problem, here's a car going along at 15 meters per second. It sees the speed limit sign up here. When the car gets there, the car is going 12 meters per second. So let me draw that up to the side. Here's the sign. It wants to know how far after the sign is the car going the speed limit. So the speed limit is 10. How far does the car go after that? So if we continue our line that we just made on our graph until it reaches 10, just kept the slope the same, it's going to reach 10 meters per second at 5 seconds. And if you're looking to use the graph to figure out how far it goes between seconds 3 and 5, because it took 3 seconds to get to the sign, and it's going to be at the correct speed 2 seconds later, all I need to do is find the area of this trapezoid. So I'll break it up into 2 segments, a rectangle and a triangle. So the rectangle is 2 seconds by 10 meters per second. And the triangle, half the base is 2 seconds, and the height is 2 meters per second. So this would be 20 plus 2, or 22 meters. Now, if you didn't want to use the graph and you just wanted to use an equation, you could have done delta x equals VIT plus 1/2 AT squared. If you're looking for the displacement, initial velocity at the sign is 12. The time after the sign that he's going to be at the correct speed is 2 seconds later, plus 1/2, and our acceleration from part A was -1, and 2 squared. So delta x would then be 24 minus 2, which is 22. Same answer. Now, part B was a little bit trickier than the rest of the worksheet. That's okay. It's good to challenge yourselves, but don't think of that as being the normal kind of problem.